You are given an array of prices where prices at index I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Let's understand the question with some examples. These are our stock price points. Let's visualize them as a bar chart where the x-axis represents the days and the y-axis represents the corresponding stock prices. Our goal is to buy the stock on one day and sell it on a future day to maximize our profit. On day 1, let's say we buy the stock at $9. But buying at $9 is not great because later the price drops to 2. Now, if we buy at 2 and then sell at 5, that gives us a profit of 3. But further along on day 3, if we buy at 1 and sell it at 7, on day 4, that gives us a maximum profit of 6, which is our answer. Now, the most straightforward way to solve this problem is for every day, try buying the stock on that day, and then try selling on every future day while keeping track of the best profit we can make. So if we buy at 9, we compare it with 2, 5, 1, and 7. Then we buy it at 2 and compare it with every future price again. And we keep doing this for every position in the array. For every element, we are scanning the rest of the array again, which gives us a time complexity of O of n squared. Can we do better? What if as we move through the array, we keep track of just 2 things, the minimum price we have seen so far and the best profit we have been able to make so far? At each step, if we find a smaller price, we update that minimum price. Otherwise, we use the current price to see if we can make a better profit, and that's really the entire algorithm. Let's walk through the same example we just reviewed. We are going to use 2 variables, min price to track the lowest price we have seen so far, and max profit to track the best profit we can make as we go through the array. We start at 9, so initially min price is 9 and max profit is 0. Next we see 2, and since 2 is smaller than 9, we update min price to 2. Then we see 5, and if we sell at 5 after buying at 2, the profit is 3, so we update max profit to 3. Next, we see 1, which becomes a new minimum, so min price becomes 1. Finally, we see 7, and selling at 7 after buying at 1 gives us a profit of 6, which becomes a final max profit. And that's the answer. So these are the 2 variables that we just discussed. Here we scan the array once. If we find a smaller price, we update minimum price. Otherwise, we compute the profit using current price minus minimum price and update max profit if it's higher. In the end, max profit is our answer.